Here is our last type of factoring. It's still within the section of factoring special quadratics. So the other special quadratic we just looked at is the difference of squares. So difference of squares, you're looking for a perfect square number, so like 4, 16, 25, 36, 49, 2 times 2, 3 times 3, things like that, and another perfect square. So same idea. It doesn't have to be a single number. It can be a perfect square where there's two of this. So perfect square minus perfect square. So that's called a difference of squares. That was one special quadratic we learned. The next special quadratic that we're looking at is called a perfect square trinomial. Okay? The middle term is twice the product of the square of the first and the last. That sounds like a lot of words, so let's just look at that for a second. So first of all, let's take a look at the first and the last terms. They have to be perfect squares, so that's a 2x and a 2x, right? So we go 2x and a 2x. Now you can look at it this way. So you can still say, well, this is still 2x and 2x, that's the first term, okay? And then you can say, okay, I'm going to look at the second term here in the 25, put that there, and break it 5 by 5. Has to be a plus, because I want them both to be the same, plus plus or minus minus. How do I know if it's a plus plus or minus minus? I look here. Because it adds to a positive, it would be plus plus. If it added to a negative, it would be minus minus. So when you look at this, you go 2x, so crisscross. So this is your first term, second term, crisscross. 2x times 5 would be 10x. 2x times 5 would be another 10x. That's twice 10x, so 10x and 10x, so this is what, twice the product of the square root, so twice the middle. That would be 20x, and that matches this 20 right here. Okay. So when it's exactly split up, they go, wait, these are exactly, remember, these are how we write our bracket. These two brackets are exactly the same. So they go, oh, that is a perfectly square binomial. So that's a perfect square trinomial because it's got double the middle, which makes it an all-square binomial. It just means two of the same type. So this perfect square trinomial isn't super, super special other than the fact that they end up being exactly the same two brackets. So you can still factor it the same way. You just realize that, hey, since there's two of the same bracket, we're going to make it all squared. So instead of writing your answer like this, I want you to write it like this, right? Clean it up and go, oh, you know what? That's my brain thinking this, but I actually have two of the same. So if you write that first, then you want to write this one next and clean it up. So let's try that again and go, okay, so if I happen to see that the first term is a perfect square, it's not a difference of squares though, right? Because it's plus 16, so it's a perfect square. You can double check it here and go like this and go 9m is 3m, 3m. And then you check the 16, which is 4 times 4. You look in the middle and go, since it's minus, then it's got to be two negatives that multiply to be positive 16, but add to be negative 24. And when you double check this, you go negative, crisscross, so 3 times negative 4 is negative 12. 3 times negative 4 is negative 12. It's two of the same, which adds to the 24. So then we know that it's 3m minus 4, two of the same, so you can do this, but I don't want you to leave it like that. I want you to write it like this. And you can skip that middle step here and just go straight to that if you see they're the same. So what they're hoping is that you don't have to do this crisscross. So this crisscross part, remember, this is all in the rough work, right? So this goes in the rough work. You can put it on a separate page or a separate column. But they're hoping that you can skip this part and just look ahead and go, look, 5 times 5, 5 times 1, and then we're just going to double check it. So for the first while, if you go, you know what, I actually still like to double check it because it makes me feel a bit better, you can still double check it on your big X. So you go 5x, and 5x, that gets me the 25, so that's this part here, first column, right, that's this one. And then the 1 would be over here, which is 1, 1. 5x times 1 would be 5x, so crisscross. And look, it's positive, and it adds a positive, so they both have to be positive. So crisscross 5x, 5x. Does that add to be double the middle there? No, it does not, so that does not work. Is there any way I can fix this around? Well, I can do 25 in 1. So I can go crisscross with the 25, but that's still not going to get me 5, so this one's not possible. Okay, so you're looking for that double the middle. The next one here, we're going to try it again. So we're going to say, okay, does this work? And again, you can still do it with this crisscross. So it still does work. It's just you're looking for the beautiful, perfect double in the middle. And sometimes for the first bit, you still just need to show the work. So this one goes here, so 2y, 2y. And then this last number here goes here, so it'll be 1 and 1. Does that get me 2y, 2y? And they should both be positive, because it's positive 1, positive. That doesn't add to be double the middle. So you go, oh, that doesn't work. So then you try again. You go, okay, so then could it be 4y, sorry, I'll do that in pink, 4y and y for this first term, and then 1, 1, still 1, 1. So that's 4 and a y, which adds to 5, and it's positive here, so it's plus, plus, or minus, minus, and they're both positive, so we're going to do this. So this ends up not being two of the same, two different ones. And that's fine. Right? Sometimes it works and sometimes it doesn't. When it's double the middle, then it ends up being exactly the same. So try it again. It's almost the same question. Look, I gave you almost the same question, but we're going to do this one again. So we're going to go 2y, try it again, 2y, 2y for the first term, and 1 and 1 for the last. And that one does end up being 4y. So this is positive, which means plus, plus, or minus, minus. But because it adds to be positive, it'll be plus, plus. And look, that ends up being 2y plus 1 all squared. Right? So again, that's your thought process. So this is special because it's two of the same. But you can go about it the same way. Right? So they're just hoping you can recognize it sometimes that it ends up being a special one. So like this one. We've got 9 and 25, so the 9 goes here. We're going to say, okay, that is 3p, 3p. The 25 would go here, so 5q, 5q. And crisscross, so look, it's positive, so it's plus, plus, or minus, minus. But because we look here, it adds to be minus, it has to be minus, minus. So if that's going to be minus, minus, that'll be negative 15 PQ, negative 15 PQ, and does that add to be the 30? Yes. And you can see it's double the middle, 15, 15, so that's why we know it's two of the same. So again, hoping that eventually you skip this part and then go, look, 3 times 5 is 15, double that, it's 30. Okay, it isn't easy to see that all the time, so if you do a bit of work first, that's okay. So 3p minus 5q, but two of them. And then again, you try it again, and you, okay, I'm going to try it one more time. So it's 49, so 7m, 7m, that's this one. 81, which is going to be 9n, 9n, crisscross. So 7 times 9 is 63 mn. 7 times 9 is 63 mn. And it's positive, so plus, plus, or minus, minus. And since that's positive, they're both plus, plus. Does that work? 126. Is that 63 plus 63? And it is. So that means it's double, two of the middle. So that's our special, last special case. There. Okay, so that is it for our types of factoring. Next video I'm going to do is going to have kind of all of them mixed up and being able to identify them all. So we'll go through that one in the next video.